Hello friends, welcome back once again in the video lecture series of data communication and networking. Its subject code is 1618502. Today I am going to teach you unit number 4. Its name is multi-channel data communication, and under this unit I am going to teach you third type of multiplexing, which is also known as WDM. This is my name and my designation. So let's start with the video. So before going video in deeper, I will teach you importantly about WDM. WDM is also known as wavelength division multiplexing. Next, I will going to teach you some basic concepts of WDM. After that, I will also teach you about WDM system, that is wavelength division multiplexing system. Later on, I will just let you know about some basic types of WDM, that is coarse WDM, next dense WDM, and after that I will try to summarize this video in the summary slide. After that, I am also going to give you some good references. So let's start with the first topic, that is basic of WDM. Talk about wavelength division multiplexing. In fiber optics communication, this is a technology which multiplexes the number of optical carrier signals into a single optical fiber. So basically, WDM is used to multiplex a number of optical carrier signals into a single optical fiber. This enables the bi-directional communication over one strand of fiber as well as multiplication of the capacity. So bidirectional means it can flow either direction. The technique is enabling in the either direction, that is from source to destination as well as from destination to source. WDM is commonly applied to an optical carrier which is a typical described by its wavelength. So basically, wavelength is the important factor for determining the wavelength division multiplexing. Actually, truly speaking, FDM typically applies to a ratio carrier which is often described by the frequency, right? And this is purely conventional because wavelength and frequency communicate the same information, right? So there is various similarity between FDM and WDM. In vacuum, the velocity of light is denoted by small c. In the glass fiber, its speed is 0.7 times that of the velocity of light in vacuum. While talking about data rate, which is ideally might be at the carrier frequency, in practical system is always a fraction of the carrier frequency. That means in WDM type of multiplexing, in practically speaking, it is always a fraction of the carrier frequency. Let's talk about some basic concepts of WDM. This WDM has long been technology of the choice of transporting large amount of data between the two sides. So whenever we have to go through the large amount of data which is to be transferred from one place to another place, at that time WDM concept is being used. It increases the bandwidth by allowing the different data stream which is sent simultaneously over a single optical fiber network. Say in WDM, whatever the channel we are using, that is we are using about optical fiber network, and in this basically several data stream which is having several different bandwidth is going to be transmitted over a single optical fiber network. Okay, WDM basically used for maximizing the usefulness of the fiber. That means when we are using fiber optics, and when we have to maximize utilization of fiber optics, generally we are using WDM. This has been adopted by carrier and service provider. That means to enhance the quality of the carrier signal in fiber optics, generally we are using or we are adopting the third type of multiplexing, which is known as wavelength division multiplexing. Today, WDM networking solutions are also available, which meets the need of the corporate enterprises, government organization, and other different organizations. So WDM is widely used in telecommunication in today's era. The solution that is simpler and more cost effective than the traditional carrier grade ones, right? Many organizations are benefited through this WDM networking, right? Okay, so this is a good example of WDM with the help of diagram. Here, this transceiver transmitting the data in the form of light. Here it goes in this way. It is being multiplexed, right? And with this one, this is the patch card which is connecting the transceiver and other multiplexers, right? Here WDM multiplexer is used for optimize the use of fiber channel in this way, right? Here multiplexer is being used, and this multiplexer is special type of multiplexer which is also known as WDM. Here we are also using dark fiber, which is a prerequisite of a WDM solution, right? Okay, so let's talk about WDM systems. So basically it uses multiplexer, a transmitter which mainly joins several signals together, and a demultiplexer at the receiver to split them apart. Actually WDM system में होता क्या है कि ट्रांसमीटर के पास we are using multiplexer. Multiplexer is used to combine the input signals, and similarly demultiplexer is used to split all these input signal into various parts. With the right type of fiber, it is possible to have a device that use them both simultaneously and can function as an optical add and drop multiplexer, right? So fiber optics is very much used in such type of WDM system when we are concerned with the multiplexer and demultiplexer. Also, optical filtering devices are having some conventional relation with each other. There are different types of the WDM, that is wavelength division multiplexing. Some is known as simple WDM. The notation WDM is also known as XWDM, and it is basically a modern system which can handle near about 160 signals with the speed of 100 gigabits per second. And when we are using single optical pair, at that time its speed goes to 16 terabits per second. So this type of system is expensive and complicated to run. This is the first property of your WDM system. Recent standardization and the better understanding of dynamics of the WDM system has been made WDM less expensive. See, earlier WDM system was expensive and they are complicated, but uh, as it has been gradually improved. So right now, what are the systems that we are using in WDM is quite cheaper as compared to the previous one, and it is less complicated. We are using wideband devices in this type of WDM systems. While we are talking about demultiplexer, it must be provided the wavelength sensitivity of the receiver at the WDM system. WDM system can be divided into three wavelength pattern. First is known as normal WDM. Next one is known as coarse WDM, that is CWDM. Normal WDM is also known as the WDM itself, and third one is known as your dense WDM, that is DWM. So we will also have a quick review on coarse WDM and dense WDM in the later section. So normal WDM is sometimes also known as BWDM, which is having the wavelength in between 1310 to 1550 on one fiber. Channel plan vary means while establishing WDM, the plan of the channel may vary, right? But the thing is that whenever we are talking about dense WDM, it is using 40 channels and the speed is 100 gigahertz, right? And for 80 channels we are using 50 gigahertz spacing. There is a good diagram of your WDM system. So through this you can well understand about how WDM system is working, right? Okay. So next talk about the second type of WDM, or the apart from normal WDM, that is known as your coarse WDM. Basically, in contrast with the dense WDM, it uses increased channel spacing to allow the less sophisticated, and thus it is having a cheaper transceiver designs. That means it is having cheaper cost as compared to your dense WDM. It provides 16 channels on a single fiber. That means on a single fiber you can embed near about 16 channels at a time, and it uses the entire frequency band spacing the second and third transmission windows, which is also known as 1310 to 1550 nm respectively, right? Okay. OH-free silica fiber are recommended if the wavelength between second and third transmission is windows is being used, right? So that is very important. If we are using second and third transmission windows, for that OH-free silica is being used. WDM, CDWDM, and DWDM, basically they are based on same concept, using the multiple wavelength of the light on the single fiber. It differs in the spacing of wavelength, the number of channels, and the ability to amplify the multiplex signals in the optical space. So, what is the difference between, or what are the different parameters for differentiating these type of wavelength? It is depending upon spacing of wavelength, number of channels that they are being carried out, and what is the ability to amplify the signals. Okay, so originally if you talk about coarse WDM, It was fairly generic and it is described in number of different channels and configurations, right? Okay. Next is what? The channel spacing and frequency in these configurations pre-included the use of erbium doped, which is also known as EDFAs, right? It is known as your fiber amplifiers. Prior to relative recent ITO standardization of the term, one common definition of CWDM was two or more signals which are used to multiplex onto the single fiber with one signal in 1550 nm band and another is your 1310 nm band. So when we are talking about ITO standardization, basically we are using the signal with having two types of band. One was 1550 nm band and second one was your 1310 nm band. In 2002, this ITO standardization, a channel spacing grid for CWDM ITU-T G694, this is the configuration given to the spacing grid which was used for the wavelength from 1270 nm to 1610 nm, and in that they were having the spacing of near about 20 nm, that is nanometers. Another type of ITU standard which is also known as G69T4.2, which was revised in year 2003 to shift the channel the center by 1 nm, so right, and they were we having the wavelength of 1271 to 1611 nm. See the difference between these two. Earlier was your 1270 to 1610, and later on it was incremented by one, that is 1271 to 1611 nanometer. So let's talk about some applications which is related to your CWDM. So it is widely used in your television network, right? Okay, then where we are using downstream and upstream signals. Okay, in this system wavelengths are often used and they are widely separated with each other. Once talking about the bandwidth, so for downstream we are using 1310 nm and for upstream we are using 1550 nm. Some JPEG or small form of factor, that is known as SFP transceivers, utilize this type of standardized CWDM wavelength, right? So for this particular application, for SFP, that is your one of the good transceivers, CWDM is widely used. JPEG and SFP CWDM optics mainly allows the legacy system which is used to convert to enable the wavelength which is multiplexed transport over fiber by selecting the compatible transceivers. These wavelengths are widely used and it is inexpensive as compared to other multiple devices. Okay, so it is also used in your physical layer standard. The example of some CWDM system in which the wavelength is normally 1310 nm, each carrying of 3.125 gigabits per second, that is gigabits per second data stream, and it is used to carry 10 gigabits per second of your Aggregated data means on an average it can also take 10 gigabits of data. While we are talking about passive CWDM, it is the implementation of normal CWDM, and it has not having any sort of electrical power. It also generates the wavelength by using passive optical components, and the passive active components are also known as such as your band pass filter and by using different prism. Many manufacturers are promoting passive CWDM to deploy the fiber to at home. See, passive CWDM is very important while using into the home appliances. Next, talk about dense WDM in short. So it refers originally to optical signals which is multiplexed at 1550 nm. So this band is used so as to leverage the capability according to the cost, right, of EDFA, that is your erbium doped fiber amplifiers. These EDFA were originally developed to replace SONET and SDH, which we have already studied in earlier multiplexing technique. It is also used to amplify the optical signal in their operating range regardless the modulated bit rate. EDFA has enough pump energy to available to it. It can amplify the many optical signals as can be multiplexed into various amplification band. This EDFA allows the single channel optical link to be upgraded in the bit rate by replacing only equipments at the end of the link. So wherever we want to install the dense WDM, at that EDFA is widely used. So this is the good example of your dense WDM, how it works. Here we are having some clients. Clients are attached with your CEOs, and again we are having WDM multiplex, and here we are having QA, that is quality analysis maybe going on. Here we are having QA DM, right? And here we are again having your QA, that is your optical amplified wavelength has to be there, and here it is being demerged, and again the input signal will be received to the same original signal at the end of the receiver. Okay, let's talk about summary. So what we have studied so far. So fiber optics communication, we are using WDM technology, which is multiplexing the number of optical carrier signals into a single optical. It is used for bidirectional communication. Bidirectional means from source to destination or from destination to source. WDM has long been technology for the choice of transporting large amount of data. That means whenever we have to transfer the large amount of data from one place to another place, at that time we are using such type of WDM. It increases the bandwidth by allowing the different data stream which is normally sent simultaneously over a single optical fiber network. Okay, so basically it increases the bandwidth of the data stream. WDM system uses multiplexer and at the transmitter end to join the several signals, right? And again, demultiplexer is used to split all these input signals at the receiver end. So in this type of WDM, we are using both type of devices, multiplexer and demultiplexer, which is also known as mux and demux respectively. With the right type of fiber, it is possible to have a device that is used for both simultaneously and can function as an optical add drop multiplexer. It is very important while we are talking about WDM. So at that time we are having so many functionality of WDM. So let's talk about references. Here are some references which can excel your knowledge. Some URL website link also provided by me to you. And if you want to go for further studies for videos, you may go to watch this video YouTube video link. So thank you. Thank you so much for watching this video. Have a nice day.